Hi, in this video we are going to implement the topological ordering or the topological sort together. So first of all, let's create a new project with the topological ordering, for example. It's going to be a Java standard edition. Okay, I'm just going to create a package with the name, for example, com.myname.topological. Okay. And I'm just going to create three classes. The app.java, from where we are going to test our application. Then we are going to have a class that's going to represent the vertices, so the nodes in the given graph. So it is the vertex. And we are going to have a class that's going to store the algorithm itself, so the depth first search basically. For example, topological ordering. Okay, the vertex class is going to store a string data, so string, for example, data, it's going to be the label of the nodes. It can be characters, node A, node B, node C, or just numbers, whatever. We have to track whether this given node or vertex has been visited or not, so we will have a Boolean flag, and basically we just have to store the neighbors, so the vertex, it's going to be the neighbor list. Okay. In the vertex constructor, we're just going to get the data, so string data, and we initialize this data accordingly. And it's very important, in order to avoid null pointer exception, first of course we just have to import the java.util.list, and secondly we have to instantiate a new array list. Okay, and then we are going to have a method, for example, public void add neighbor. It's going to get a vertex. Okay, and we just have to add it to the neighbor list. Add the given vertex. Okay, I'm going to override the toString method, and we just have to return this.data. So return this.data. Okay. And anyways, I'm just going to generate getters and setters. So generate getters and setters for the data, the neighbor list, and the visit. Ctrl-Shift-F to auto format. And basically, as we have discussed in the theoretical section, the topological ordering relies heavily on depth first search. Okay, we could do it with the help of matrix multiplication, but the most common technique and algorithm is to use a depth first search. Okay, so in this topological ordering class, we are going to have a stack of vertices. It's going to be the stack, for example. Okay, not that good name, but whatever. We just have to import the java.util.stack. And we are going to have a constructor, so the topological ordering constructor. We just have to initialize and instantiate this stack. It's going to be a new stack. Okay, and then we are going to have a method, public void DFS. It stands for depth first search. We have a given starting vertex. Okay. Basically, we just have to set this vertex to be visited. So set visited true. And we have to iterate through all of its neighbors. So vertex v in the vertex.get neighbor list. Okay. And we just have to check if we haven't visited. So if this v is not visited, which means that we haven't visited this node, then we just have to visit it recursively. So that's why we call this DFS method recursively on the neighbors if we haven't visited that given node. Okay, and after we have finished visiting with all the neighbors, we are going to call the stack.push with the given vertex. Okay, we just push it to the stack. And we are going to have a helper method, basically a getter for the stack. So we're just going to return a stack of vertices, for example, get stack. And here we're just going to return this.stack. Okay, so that's all about the topological ordering. We have already discussing depth first search, so I'm not going to talk about it. We know for certain that, okay, we get a given vertex, we are able to implement it in a recursive manner. The operating system is going to use a stack as an underlying abstract data type. For breadth first search, we have to use a queue. For depth first search, we have to use a stack, but the depth first search can be implemented quite elegantly with the help of recursive method calls. So we just have to stack that when we finished visiting a given vertex, so that's why we push it onto the stack. Okay, and in the application, basically, we just have to create a graph. I'm going to create it in the next video. Thanks for watching.